Okay, so this is a recording about the conditions for parallelograms. This is ways that you can prove that something is a parallelogram. One that is not going to be listed because it's already there is the definition of a parallelogram, which is that both pairs of sides of a quadrilateral are parallel to each other would make something a parallelogram. Okay, so the first one we're going to get is that if both pairs of opposite sides of a quadrilateral are congruent, then we have a parallelogram. Okay, so we're going to prove this. I'm going to create a quadrilateral. We're going to call it QRST. We're going to throw this in there because we're going to need it. Call that 1, 2, 3, and 4. And we're going to be given that the opposite sides are congruent. So if both pairs of opposite sides are congruent, then we're going to have a parallelogram, right? So we're going to be given that the opposite sides are congruent. So we're going to be given that segment TS is congruent to segment QR, and we're going to be given that segment TQ is congruent to segment SR. And we want to prove that QRST is a parallelogram. Okay, so the only way that I can prove that something is a parallelogram at this point is by the definition. So ultimately, the definition says that I think the opposite sides parallel. So I have that they are congruent. I want to show that they are parallel. All right, so let's just get all the givens on the board. Segment TS is congruent to segment QR. Segment TQ is congruent to segment SR. And we know this because it's given. A real easy move to make here then is to say that segment QS is congruent to itself. And I know that because of the reflexive property, which now gives me that triangle QST is congruent to triangle SQR, and that's by SSS. Okay, so it's not hard from here, because now that I have these two triangles congruent, I can get some angles, and then I can use the angles to get the lines being parallel. So I'm going to say that angle 1 is congruent to angle 2, and we're going to say that angle 3 is congruent to angle 4. And these are both sets of corresponding parts of the congruent triangles, so we use CPC, TC. If 1 and 2 are congruent, that means that TQ is parallel to SR. If 3 and 4 are congruent, that means that TS is parallel to QR, and that's by the converse of the alternate interior angles theorem. So now I have TQ being parallel to SR and TS being parallel to QR, which means that I have a parallelogram. QRST is a parallelogram by the definition of a parallelogram. Alright, so that one tells me that if I have both pairs of opposite sides being congruent, then I have a parallelogram. Okay, so the second way, well, third actually, because we have the definition and now we have pairs of opposite sides being congruent. The third way that we can prove that a quadrilateral is a parallelogram is that if the opposite angles, both pairs of opposite angles are congruent, then we have a parallelogram. Okay, so let's start with a drawing again here. Let's call this QRST. We're going to label these as X, and we're going to label these as Y. So we're going to be given that the measure of angle T is equal to the measure of angle R, which is equal to X, and the measure of angle Q is equal to the measure of angle S, which is equal to Y. So the opposite angles of my quadrilateral are congruent. And we want to prove that QRST is a parallelogram. Okay, so this is pretty straightforward as well. So we got statements, we have reasons. All right, so we have this measures here. Measure of angle T is equal to the measure of angle R, which is equal to X. And we know that the measure of angle Q is equal to the measure of angle S, which is equal to Y. And we all know all of that because it's given to us. Okay, now, that being said, I have a quadrilateral. N minus 2 times 180 is, well, let's see, that's 4 minus 2. That's 2 times 2, or 4 minus 2 is 2. 2 times 180 is 360. So if I add the 2 x's plus the 2 y's, I have to have 360 degrees. So this is the polygon angle sum theorem, right? The angles have to add up to n minus 2 times 180. The number of sides is 4. 4 minus 2 is 2. 2 times 180 is 360. Okay, so divide everything through by 2. That means x plus y is equal to 180. That's a division property. And lo and behold, that means that angle T and angle Q are supplementary. It also means that angle Q and angle R are supplementary, which means if these two are supplementary, if T and Q are supplementary, then TS has to be parallel to QR because the same side interior angles are supplementary. And likewise, if these two are supplementary, because those add up to 180, then TQ has to be parallel to SR, again because of this is the converse of the same side interior angles theorem, right? If the same side interior angles are supplementary, then the lines have to be parallel. If I have both sets of opposite sides being parallel, then I know that QRST is a parallelogram. And how do I know this? Because of the definition of a parallelogram, which says that the two sets of opposite sides are parallel. So at this point, I now have 3 ways to prove a quadrilateral is a parallelogram. I can use the definition and show that the two sets of opposite sides are parallel. I can use that 2 sets of opposite sides are congruent, will give me a parallelogram. And then I can also use that the 2 sets of opposite angles are congruent, would give me a parallelogram. All right, so there's actually more ways to do this yet to come. So let's look at another one. Okay, so here what we're going to say is I'm going to say that one pair, not 2, but one pair of opposite sides is both congruent and parallel. If I have that, then I have a parallelogram. So I have a quadrilateral where one pair of opposite sides is both congruent and parallelogram. I have and parallel, then I have a parallelogram. So let's look at how this might get proven. So let's start with QRST. Now I'm also going to need a diagonal here. We'll call this angle 1. We'll call this one angle 2. And we're going to make TQ and RS congruent. and we're going to make them parallel. So we're going to be given that TQ is congruent to RS and that TQ is parallel to RS. And I want to prove that QRST is a parallelogram. So let's make statements and reasons. Okay, so right off the bat, I have a bunch of information. TQ is congruent to RS. TQ is parallel to RS. I have that because it's been given to me. Okay. If these are parallel, then angle 1 has to be congruent to angle 2 because they're alternate interior angles. So that makes that congruent to that. I also know that QS has to be congruent to itself. That's the reflexive property. And that gets me the two triangles being congruent. Triangle TQS is congruent to triangle RSQ, and that's by side angle side. I have a side, an angle, and a side. I have a side, an angle, and a side makes those two triangles congruent. Why did I do that? Because now I know that TS is congruent to QR by CPCTC. So this has to be congruent to that. And now I have the opposite, both pairs of opposite sides are congruent, which means by earlier theorem that QRST is a parallelogram. Both pairs of opposite sides are congruent. Both pairs of opposite sides are congruent. Then I have to have a parallelogram. All right, so here's where we are. We're up to 4 methods. 1, the opposite sides are parallel. I have a parallelogram. That's by definition. 2, opposite sides are congruent. I have a parallelogram. Opposite angles are congruent. I have a parallelogram. That's 3. And 4, if one pair of sides is both congruent and parallel, then I have a parallelogram. We have one more. Okay, so this one says that if the diagonals of the quadrilateral bisect each other, then I have a parallelogram. So if the diagonals bisect each other, I have a parallelogram. So let's build a quadrilateral. Let's put its diagonals in. So we're going to call this T, S, R, Q. We're going to call that point M, and we're going to be given that TR and QS bisect each other. And we want to prove that that means that QRST is a parallelogram. All right, so let's do statements and reasons. Okay, so we have that TR and QS bisect each other. Right, and how do I know that? Because it is given. All right, so that means a whole bunch of stuff. That means that TM is congruent to MR, and QM is congruent to MS, because that's the definition of a bisector. Okay, so we just said that this is the same as that, and this is the same as that. So let's get a whole bunch of angles here. Angle TMS is congruent to angle RMQ. That's congruent to that. Likewise, angle TMQ is congruent to angle RMS, so this one is congruent to that one. That's because it's a vertical angles theorem, which gives me the right to say a whole bunch about a bunch of triangles. I have triangle TMS congruent to triangle RMQ, and I have triangle TMQ being congruent to triangle RMS. Both of these are by side angle side. Side angle side with side angle side. So that's these two triangles being congruent. You can play the same game with the one on the top and the bottom. Okay, so we proved triangles congruent to get CPCTC. Easiest thing to do here is to say that TS is congruent to QR because that's in the top and the bottom triangle. TQ is congruent to SR, that's in the left and right triangle. That's by CPCTC, which means that QRST, because if this is congruent to that, and that is congruent to that, then this has to be a parallelogram, because both pairs of opposite sides are congruent. Let's real quick recap that there are 5 methods. 1, opposite sides are parallel. That's the definition. Would get me a parallelogram. Opposite sides congruent gets me a parallelogram. Opposite angles congruent gets me a parallelogram. 1 pair of opposite sides is both parallel and congruent, gets me a parallelogram. And the last one, the diagonals bisect each other, is going to get me a parallelogram. So this is 5 ways of proving that a quadrilateral is a parallelogram.